One last question to kind of show how to use this program. So determine the number of valence electrons in iodine tetrachloride, and then draw the corresponding Lewis structure. So for this question, right, iodine's a halogen, it's got 7 valence electrons. Chlorine is also a halogen and it has 7 valence electrons. Got 4 chlorines, so that's 28 electrons from chlorine, 7 from iodine. So that brings us up to 35 valence electrons. And then the -1 adds in 1 more valence electron. So I've got 36 valence electrons to assign. Let's put those into a Lewis structure now. Again, I would start with iodine, right? So we want to put the least electronegative element in the center. And electronegativity, right? The farther to the top right of the periodic table, the more electronegative. So iodine is below chloride. So iodine would be the least electronegative element in this case. So I'm going to put iodine in the center. And then I need to have 4 chlorides surrounding it. So with iodine still highlighted, I'm going to go to 4 bonds, and then I'm going to make each of those bonds a chloride, right? So there's 1, there is 2, there is 3, and here is 4. All right, so there I just used 8 of those 36 electrons, so 28 electrons left to assign. I'm going to fill the octet of all the chlorides. So there is 6 of my 28 that are left. So I'm down to 22. Going to use 6 more. So that's going to take me down to 16. 6 more is 10. And then 6 more is going to take me down to 4. So I filled the octet of all the chlorides. Iodine does have a full octet currently, but we've got 4 more electrons to assign. Iodine can have, it can break the octet rule because it has access to d electrons. So those remaining 4 electrons, I'm going to assign those to iodine. And there we are, right? We're in the octahedral electron domain geometry, right? And we're going to be a square planar molecular geometry for this molecule. And then one more thing to cover, right, is where is that formal charge located, right? The formal charge is group number minus the assigned number of electrons. All of these iodines, even though it doesn't look like, it looks like it's missing one of the electrons right here, it's just because they're on top of each other. So both those electrons are there. All of the chlorides, right, they're group 7, they've got 7 valence electrons assigned, right? So 1, 2, 3, 4, 5, 6, and then 1 electron for the bond, 7. So 7 minus 7, all these chlorides are neutral. The iodine, however, is group 7, and we're going to count the assigned electrons. We count all of the non-bonding electrons. So there's 4 electrons there, and then 1 electron for each of the bonds. So there's 5, 6, 7, 8. So 7 minus 8, the -1 would be assigned to the iodine in this structure. It's not asking us to assign that formal charge, but it would be on that central iodine. But we're done. We've assigned all 36 of those electrons, right? And now we can show the answer and correct. We've got the correct Lewis structure, and we've got the correct number of valence electrons that we had to assign. So hopefully that gives you a pretty good idea of how to use this program. I think one more thing I didn't get to would be, how to form double bonds maybe. And to do a double bond, so for example, where we would need a double bond, if I just click on that double bond, and I can go from double, right, to triple bond as well. That was one last feature that I don't know if it's come up or not, but that would be how we would do that. So for example, if I wanted to make oxygen, right, O2 has a double bond in it. So we would just click between those two to highlight that and change the number of bonds. Or if I wanted to make carbon monoxide for carbon dioxide, for example, right, put that as carbon. Carbon's going to have 2 bonds. I'm going to make that a double bond, and I'm going to make this oxygen if we wanted to make carbon dioxide. And then the last thing would be to fill out our octet. I need 4 electrons there and 4 electrons there. So that would be the last feature of how to change the order of the bonds if you do need that, right? We're just going to highlight the bond, and then that will let us toggle between, do I want a single, double, or triple bond in those cases. So hopefully that covers anything that might come up in making these Lewis structures. If not, don't hesitate to send me an email. I'll be happy to work through some of these questions with you.